All right, moving on, looking at number 20, we're still looking at what we would consider to be a special right triangle. And I know that because it's got a right angle in it and it has a 45-degree angle. That's one of our special right triangles. So I always start out by labeling those sides like I showed you, x, x, x root 2. And I'm going to continue doing that in these problems. So this is labeled x, happens to be the same x. X, these are two legs opposite 90-degree angles, and this side would be x root 2. Okay, so this is the only side we know both pieces of information in. So if x root 2 happens to equal 11 root 2, we can solve that equation if it doesn't come easily to you. But basically I'd be looking to solve for x, divide by the root 2 that's being multiplied by it, divide this by the root 2, and those cancel out, which would tell us that x would equal 11. So that's what x happens to equal. Moving on to number 21. These sides are in a different order, but they're also a special right triangle due to this 30-degree angle and this 90-degree angle. I'm going to label those sides like we talked about. Opposite the 30, I always start with the smallest angle, is x. Opposite the 90 is 2x. And opposite the 60, that will be over here, is x root 3. So once again, we only have one side where we have an actual number set equal to something with x in it. So if 8 root 3 equals x root 3, by the same logic, if we divide both sides by root 3, we end up with that x equals 8. So that's over here at this value is 8. This side right here, the y side, y should represent 2 times whatever x happens to be. So since y is 2x and x is 8, that makes y 16. All right, moving on to number 22. Once again, special right triangle. We know this because we've got the right angle, we've got the 45 degrees. We label all the sides. Opposite the 45s are both x. Opposite the 90 is x root 2. And we look for that side that has both pieces of information. That's this hypotenuse. So this one's a little bit more complicated to solve, but we can do that. We see that 12 represents x times root 2. To solve for x here, I'm going to divide both sides by root 2 to get it alone. And when we look at it, we really, we'd love to leave our answer like 12 divided by root 2. However, we're not allowed to leave a radical in the denominator. So in order to get rid of that, to avoid it, we do something called rationalizing. Rationalizing means we take whatever the denominator happens to be, which is root 2, and multiply the top and the bottom by root 2. Now in the numerator, I have 12 times root 2, and in the bottom, I have root 2 times root 2, and root 2 times root 2 is just 2. Okay, almost done. I wish I was finished now, but I'm not quite. We can actually also simplify the 12 and the 2. 12 divided by 2, since neither one is under a radical, we can divide them, and that would be 6, and we still have that root 2 left over. So that's what x happens to equal here, 6 root 2. Okay, moving on. This is also a special right triangle. We have our 90-degree angle. We've got our 30 degrees right here. We'll label our sides x. Opposite the 90 is 2x. Opposite the 60, which is right here, will be x root 3. Okay, so let's look for the side that we have both pieces of information. That's right here. So 2 times x equals 12 root 15. If I want to get x by itself, I divide by the 2 that's with it. And if I divide by 2, 12 divided by 2 is 6 root 15. That's what x is. It's not pretty, but that's possible. Okay, moving on to y, which is right here on top of that triangle. Y we said is equal to x times root 3. And since x is 6 root 15, we're going to multiply that by root 3. Now, if you remember talking about multiplying radicals, we are allowed to multiply the numbers outside. So 6 times, this one really has a 1 outside, so 6 times 1. It stays outside. And then I multiply the numbers on the inside, root 15 and root 3. That's root 45, because 15 times 3 is 45. 45 we actually have to simplify because it has a perfect square in it. 45 is the same thing as 9 times 5. And 9 is a perfect square. Once we can take a number's square root where it's allowed to come outside of the radical, so we still have a 6 there. The 9, when it comes out of the radical, it becomes a 3, and that 5 is left behind. Ooh, and I wrote a 3, but I meant to say that 5 is left behind. And 6 times 3 actually equals 18. So this is 18 root 5. That is what y happens to equal.